Good evening, everybody. Kimball here, aka Light Miser. So here I've done a quick mock-up of the sensors to make sure that my code there is going to work and that these sensors are good, since they're new out of the bag and I haven't tested them yet. And it's a bit of a clutch here, and I know I mentioned that I wasn't planning on using a breadboard for the actual wiring of this, but this is just to do a quick test to make sure everything's up and running. So these PRs themselves are pretty simple to wire. So for each one you've got your ground, your high-low output, which is your actual trigger, and your power. So for each one I've got the ground connected up on the ground tab here on the breadboard, the hot line plugged into the hot line here, and each of those corresponding plugged into the Arduino itself, and then the middle line, which is the control line, I have wired in on plugs 2 through 5. So now if I do this real quick, let's see here, almost made it. Still getting used to the software, sorry everybody. There we go. And this is the code that the link to the GitHub project will be linked down below. But you can see that this is the basic code for this project. So I've got the PIRs on ports 2 through 5. On the setup here, you're setting each one of those, telling the Arduino those are going to be inputs. In this case, you can also do it for outputs, depending on what you're doing. Here we're just testing the inputs. By using the serial, you can then use the serial monitor to write out text so you can see what's going on as a way to debug. You'll see that later in the code. Now here's the main loop, and it does what it says it loops. So it'll loop, wait for half a second, loop again, and just continue that loop until, well, the entire time the device is active. If you don't have the serial monitor on, you just won't see what it's doing. The basic looping function here on the Arduino is the main program that's going to run when the Arduino powers up. That's why I use these a lot for building electronics for presentations, because it's a simple loop that you can also do functions with, that it'll do the same thing time after time after time very reliably. So in each loop, it goes through and it reads each port, and it's a digital read, and it shows it either a low or high with these type of devices. And for each one, if it reads it as a high, meaning it sees motion, it's going to print out the motion was detected. 1 through 4 there. So now when you're first working with their Arduinos, unfortunately the software is not showing the context window here. Let's see if I can do it if I move over to the full display. So when you're first connecting up, you need to make sure which port you're on, and that you're connected to the correct port. Mine happens to be COM5. Windows 10 told me it was COM5 when I was plugging in this Arduino board. You can also find it from the device settings. If you right click on Start here, go to Device Manager, and go to your ports. It'll show you what ports are being used on COM and LPT. LPT is the old printer port, and the one you want is COM5, which is because it's a USB serial device. And you can double check that by, once you have it set to the correct port and the correct type of board, this is an Arduino Uno, then you can do Get Board Info, and it'll show you the serial number, the USB vendor ID and product ID, and the name of it, which is an Arduino Uno. So we know we're good to go there. Then when you want to check your code, hit the check mark there to verify that it's good code. It'll go through and do a quick compile. Expand that out a bit there. In fact, let's do this. A little easier to read. And it'll tell you about the code you just compiled. That's using 2,182 bytes of storage, which is about 6% of the storage space you have. The maximum is 32,256 bytes. So you got decent size room here on this particular device. They make smaller ones, they make bigger ones. Then it lets you know where that memory is being allocated at. 300 bytes or 14% is for global variables and dynamic memory, leaving 1,748 bytes for local variables. The max is 2,048. So this is very small code. It's not stressing this device at all. So now we go back over here. So now when you're ready to actually push the code to the device, you're plugged in, you've got it set to the right COM, hit your upload button, and it's uploaded. Well, how do we know? You come into Tools and turn on the serial monitor. Now, my hand happens to be pointing by where one of the sensors are. And you can have the sensor on already when you push out. It doesn't hurt anything that way. So now I'm going to do a window in a window here. There we go. Let's move this down over here. Try to make that a little bigger. So now, when you see motion here, there's sensor 4, there's sensor 1, sensor 2, and that's sensor 3, which is also being detected whenever I touch the mouse. And of course, when this is being actually mounted in, we'll have each where we're detecting the beanbag at each location will be more controlled, so we don't get a lot of false positives. One way you can do that, because these do have Fresnel lenses on top of these sensors, is by putting PVC around it to block in any side view, and that just comes down with testing. But we know that the sensors now work, and so the next step is to connect up to the serial board, or the TTL to RS-45 conversion board, to make sure that the display board is going to work, and then finish out the rest of the logic. And here in my box of tricks, my conversion board came in. I've actually got two different types. I'm going to try this one first, and that is the conversion board. It's out of China, so it's actually hard to find any real specs on it. Yeah, is that going to focus? Nope. Too much background noise. But it lets you know right here what your connections are. Ground, your 5 volts on this side, and which one's RX and TX. And then on this side, which is actually going out to the device, you have a ground line, which I'm probably going to ignore for this hookup. And then your A plus and your B minus, which are your serial connections. So pretty straightforward wiring there. So that's my next test, is to see if I can get the display board to actually make sure I can control the display board. I mentioned I was going to look up specs on the power usage on this. Let me find that my notes real quick there. I meant to have that up already. In fact, one sec. Is rated with the transformer chips on it at 800 milliamps. Each of these PIRs will draw 0.05 milliamps, and the relay I'm going to use, again, this is assuming that I'm going to need a DC relay. Grab it here. And again, it's beefy solid state. And looks like my video screen has frozen. Yeah, my video screen's frozen. Oh well. Anyway, it draws a max of 6.25 milliamps, and so my total draw without the TTL to RS-45 is 6.45 milliamps. I couldn't find any specs on the board itself for the conversion. I'm willing to bet it's no more than half a milliamp. So we're way under the power consumption rate on this. So I'm not worried about overdriving it. I've had some projects where I did overdrive it, and what would happen is the Arduino would reset itself when its current draw would get below what could be handled. And when that becomes an issue, then the trick is to run an external power supply for these devices and just have the control line going in. And you have to get a little squirrely with the COM lines, the negative line, but nothing that's not you can work around. So that's not going to be an issue on these devices. So the next video is I'll start playing with that TTL to RS-45 and see if I can get that to talk. Well, have fun, guys.